Welcome to This Wasn't on the Test, the podcast where knowledge meets humor in the most unexpected ways. Join Dr. Jake and Dr. Kayla, a couple with doctorates in their respective fields, and their sister Kelsey, who may not have a PhD but sure knows how to keep things light with her quick humor and relatable take on the world. Whether you're a scholar or just a curious mind, this trio will make you laugh, think, and you might even learn something new. Tune in to find out why this wasn't on the test. Welcome back to This Wasn't on the Test. I'm Kelsey, and I'm here with my brother, Dr. Jake Berg, and my sister-in-law, Dr. Kayla Berg.
Hello.
Hey.
Hey-o, they say.
Hey.
How's it going?
Oh,
Good.
you know. Back in the swing of school things. Ish.
Oh, yeah.
Oh, yeah. We had open house last night. And then an event for incoming 6th graders today, which is always a good time.
Nice.
It's just a lot of large groups of people all in a row.
I get that. I work at a college, and we have new student orientation, and there's like 10 of them between now and August 14th.
Oh, my God, I bet.
And there's hundreds of students. It's insane.
At least you got a whole campus to spread them out. It was chaos.
Oh, no. We do it all in one spot.
Well, but they don't they go around campus and stuff?
I mean, after they're there for 4 hours doing all of their financial stuff and everything all in one space, and then going between, they like bring, instead of having them go out to all the different schools to like explore things, all of the different schools have a table in one of our event spaces. So then the students walk around to it, and then they go find their classes, but generally a lot of them don't even do that. Like, they just go to the event and then leave.
Yeah.
So it's all in one spot. But, you know, they're not consecutive days. It's like one was on Tuesday, and then on Wednesday in that same space we had a different event, so we had to flip the space. And then today, this was Wednesday. So we had one on Monday. Tuesday we had a different event in that space, so we had to flip the space. And then today we had that same event, so we had to flip it back for this event.
Oh, my gosh.
Oh, yeah, so you can't just keep everything set up for the next one.
Right. So that's fun. I mean, it is fun. It's fun seeing all the students come back.
Well, I found out now this year Emmy is going to be going to school at the same school that Kayla teaches at, which is really exciting.
Super exciting.
But now, we're doing the back to school stuff, and, you know, Kayla has to work the events for incoming students at her school, but our kid is supposed to be attending those, so, you know, I'm taking those, which obviously is no problem. But now
Jake is having a very different experience navigating the world of education solo.
Yeah. Well, it's kind of been weird because Kayla's got a lot of Emmy's stuff sorted already.
Mm-hmm.
Since she's there, she can kind of do that stuff by hand. And so it means that, so we had this open house, but Kayla had already done the stuff that you normally do when you walk in there. And that actually kind of caused some problems because I didn't go through the process that they're kind of intending the open house to have for parents.
I was trying to help him by streamlining and getting some stuff done together, but then he didn't know what he was supposed to do because
we didn't go
what he was supposed to do was not what everyone else was doing.
When you walk in,
because I had done all that.
Some steps.
Yeah. When you walk in, it says okay, everybody go here first and then go here, and it's Kayla had done the things that you do there, stuff. And so I didn't go see there at those places, which actually had some extra instructions that I didn't get.
Sorry.
And this is how I found out that the room numbering system in Kayla's school makes 100% no sense whatsoever.
I forget this because I've been there. This is my 14th year in this building. So I know pretty much the numbers and stuff, and I can tell you, you give me a room number, I can tell you what hallway it's in. But whoever designed these room numbers was drunk as a skunk when they did it.
Like,
Because
Well,
there
actually,
is
that happens. It's really common, actually, in educational facilities because different districts and colleges and schools and everything like that, they all get grants that they have to use, and so construction happens, and then they have to get a different number, and then it gets all misnumbered, and then all of a sudden, next thing you know, it's 40 years later, and all of the numbers are different.
This school's
not that old.
less than 20 years old.
Less than 20 years old.
So they've had no expansions or anything on this yet. It's so bad, Kelsey.
Internal construction?
No.
Like, listen, it's 90% of the numbers. If it starts with a 100, it's downstairs. If it starts with a 200, it's upstairs. Except for 1/2 of one hallway.
Yeah, it's so bad that you can't even rely on the first digit to tell what floor it's on.
There's 1/2 of one hallway that's downstairs, but all the room numbers start with a 2. And then, like, it doesn't make sense either. Like, my room is 249, but across the hall from me, like, no other rooms in between me and across the hall. Right across the hall from me, like, end of the hallway, right across the hall, is 247. There's no 248. It doesn't exist. There isn't one.
Yeah. Like,
well, is it only odd numbers? That's
no,
But then the
odds
one
on
next
this
to me,
side, evens on this side.
But then the one
none of
next
that.
to me is 250.
Yep.
Like, it is the most
so bad
asinine numbering system. And I forget that it's this way because, like, I just know, like, tell me the teacher's name, I know where they are.
Yeah.
And so I forget. And then about open house time every year, I remember that these numbers make no fucking sense.
It turns out
Do they have
that in
maps
the
for
room.
everybody?
Well,
funny you should say that, Kelsey.
we did have little half sheets of paper that says, like, these rooms are upstairs in this hallway, because all of our hallways are, like, color coded.
They were in the room that I skipped because Kayla.
They were in the room that Jake skipped because I had done all the paperwork in there ahead of time, so Jake didn't get a map.
Oops.
I was over here trying to help. I'm doing the Lord's work, and
then
I ruined everything.
And then they have a sign, like, right before the stairs in the hallways, and it looks like out of a cartoon with arrows pointing different, like, 6th grade this way, and 7th grade that way, and 8th grade up, and it's like.
And then our
Oh
kid
my
is in
gosh.
even a weirder situation too, because she has, like, she's a 6th grader taking 7th grade math, so that's in the math hall, or that's in the 7th grade hallway. Well, she's also taking, her science teacher teaches both 6th and 7th grade, so he's in the 7th grade hallway. But then one of her related arts teachers teaches all grade levels, but based on location, her room's in the 8th grade hallway. So as a 6th grader, she's in the 6th grade hallway like once. So
That's funny.
I mean, it's nature of the beast.
Well, at least she has friends in the higher grades than her.
Yeah. And she did so.
I mean, she's been in this school for years.
Since she was born.
So she knows the layout like the back of her hand.
God, yeah.
Except for maybe the specific room numbers. So it's not going to be a problem, but
No.
Yeah.
No. She was already plotting out today how to get to her different classes. And then, so I made her go today to the, like, 6th grade orientation event, even though she's in there. I'm like, no, you're going to go. You're going to meet other children. You're going to do stuff. Well, found out that one of her friends that she went to preschool with and then did gymnastics with for a while is actually going to be in 6th grade at the same middle school. She's very excited about that.
Nice.
And then she made another friend. And the irony of her making this other friend was that once upon a time when we were not heathens and went to church regularly, these two children were, like, in the nursery together. Like, this family sat in front of us in church. So we've known this child since she was a baby. And now they're now they made friends today, like 2 peas in a pod. And, like, one of the other teachers who did not know this weird distance relationship, she's the basketball coach, and the other little girl plays basketball. And she's like, I saw Emmy and, other kid's name sitting next to each other. She's like, I need that friendship to happen. It's perfect. And I'm like, funny story. They don't remember this, but they actually know each other. But no, they're like instant friends.
Is the other girl's family still part of the God Squad or what?
Ish.
Ugh.
I'm not entirely sure because that church has gone through a lot of changes since we were last there. Once upon a time, it was a Methodist church when we went there. And
I know the one.
You know the one, yeah. It was a Methodist church when we went there, but the Methodist
They
church
voted to leave the Methodist church.
when the Methodist churches decided
when the United Methodist, like the congregation,
they have a conference every year to decide on like how they're going to structure different things, and they voted to allow like to continue allowing like members of the clergy to be part of the LGBTQ community, and also for members of the clergy to perform LGBTQ weddings. And so when that happened, a lot of the Methodist churches decided to leave the Methodist church and become their own independent church. And that's what happened to this
the organization.
church. So I wouldn't go back if you paid me, because that was they are no longer a Methodist church. They're an independent church because of this decision.
No, I'm sure they haven't done enough progressiveness, but they did, as an organization, make the progressive choice to move forward.
Right.
But they were like,
a lot of churches.
They were like, but they proactively said, this isn't going to be popular. We'll let you leave.
Yeah.
So
individual churches voted whether to stay or leave, and this particular church voted to leave. So I don't know if they're still going to this church, and it was more of, she usually went with her grandparents kind of situation.
Oh, I see.
So
I was gonna say, if they still go to that church, that gives me the ick.
Yeah, but she's a precious ray of sunshine. This little child is a sweet baby angel.
Nice.
So I was very excited that by the because they got grouped together randomly, and by like the second session that they were in, they're like 2 peas in a damn pod. I was like, perfect.
That's awesome.
New friends. So
yeah, add
Fun
more
stuff.
to her little girl gang.
Yeah, I love a girl gang. So it's been interesting being a teacher and parent at the same time this year with her being in my building. It's been weird.
I'm sure it'll get weirder.
I'm sure it will.
You aren't even back in session.
I know. I'm sure it will. But here we are.
Cool. Well, that's exciting. It seems weird that you guys are already starting school.
Next week, Thursday.
Yeah, that's crazy. Why would you start on a Thursday?
I can tell you why. So, funny story. This is going to be a brief story. So, we have a teacher work day on Monday. We have what they
story
call...
time over.
What?
You said it was brief.
What?
Just kidding.
Shut up. We have opening day on Tuesday. And then they always leave one day between opening day and students coming back. And I'm convinced that the district has decided that teachers are going to use this day to work and get their classrooms and stuff set up. So that is the one day I refuse. Because I'm like, I'm not working for free when you want me to.
Yeah.
I refuse. I've been going in the evenings and extra days to get my room ready. I won't do it on that day because I know that's what they want me to do.
Yeah.
So that's why we have to to work
stupid.
Monday, Tuesday, and then Wednesday is this weird nothing day.
Wow, that's so weird.
So yes, we started on Thursday.
Should we get into it right away?
Let's get into it.
I know we just before we hit record said what we were talking about, but we all know that I have the memory of a goldfish.
Mm-hmm.
So, I do remember Jake is talking about Heisenberg Uncertainty
Yep.
Principle. There you go.
What's the difference between uncertainty and principle? Will you answer that today?
Yeah.
Okay. Never mind.
And Kayla is talking about bullying. So
There you go.
let's start with Jake first. I make the executive decision.
He got
here,
to go first last
saying,
time, but he went first last time. No, I don't care.
Okay,
I don't care. No,
first.
it's fine. I'm just used to you bullying me.
Well, are you gonna give me some lessons today? Cause
hell yeah.
Great, I need them because I need to tell my kids because they're fucking bullying each other all the time.
Yeah, they are. We witnessed that.
God.
Anyway,
If
am
they're-
I going first?
If they're not
Painful.
fucking with each other, it's tattling about who's fucking with each other, and it's the both of them.
Oh my God.
I'm like, you probably
Today I
both
told
did
them-
something stupid. Stop.
Yeah, today I said, I need you. I need nobody to talk for a little bit. Thanks.
I just said that to Emmy a little while ago. We were watching TV together, And like every 30 seconds she had something to say. And I'm like, Emmy, I love you so much. We've spent the entire day together and it's been great. But for the love of God, please stop talking.
Yeah.
Okay.
That's both of my kids.
All right, Jake.
Okay, so I'm going. So the answer to your first question is kind of related to my first question.
No shit.
So like the principle means that there's a rule related to uncertainty as a property, I guess, if you want to think of it that way. So like my first question is just like so rules in physics. There's a lot of like rules and laws, they call these things. So Heisenberg's uncertainty principle it's kind of just another synonym for like a rule or a law, and that's just the name that this one ended up with is Heisenberg Uncertainty Principle. So
I'm assuming
it's a law that governs uncertainty, and that rule was kind of postulated by Heisenberg, so it ends up being called the Heisenberg Uncertainty Principle. So that's your answer for that one.
Okay.
So, but
I see it.
My first question is, like, what does the uncertainty of a measurement mean? That's where we need to start.
Does that have something to do with the ladder in the barn?
Why do you keep bringing it up? That's done and over with.
No, because like uncertainty of measurement, that seemed like a very uncertain measurement to be able to fit a ladder in a barn, but not. Anyways.
Kayla's obsessed with the fucking ladder in the barn.
Oh my God.
Jesus, move on.
Tore up about the ladder in the barn. Does it have
take the ladder and take it out of the barn and get over it.
I'm gonna take the ladder and shove it up your ass. Anyways, so uncertainty of measurement specifically, you say?
I mean, that's what we're talking about.
Okay.
Is like in terms of like any sort of measurement of something. Like, what does the uncertainty of that? What does that mean? When somebody
I feel like
uncertainty?
to me that means that it's like inexact in that like it's uncertain based on other conditions and parameters.
Okay, that's a good start. Yeah.
Thank you. Yes. Your turn, Kelsey.
I feel like most science, it's made up, and so they have to say uncertainty because they have to because they have to, it's, science is just kind of like a, you know what I mean?
It's like unicorns.
Yeah. It's like they have this like hypothesis or like this whole thing, and it's like this would work. Like this would work, but we're uncertain because we've never witnessed it work.
Okay. So not like magic, more like theoretical.
Theoretical.
Okay.
Yeah. Like
okay.
Yeah, like the math. All of this math says it should work. All of this other research that we've done would say it works. Blah 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 blah. But we can't get it to work, so we're a little bit uncertain. But that's why it's this like theory.
I mean, I guess think about it. If you go and step on a scale in your bathroom, it's like a digital one, and it only goes out to a certain number of digits. Probably, maybe not even the 10th digit, right?
Mm-hmm.
But that your weight is not precisely like whatever number 0.30 is going to infinity, right? So like when you step on a scale and you see that number, like what is in your mind thinking of like the range that your scale is kind of correct within?
I mean,
I round down 10 at least.
10 pounds?
Yeah, so I mean,
Kelsey's like, scale says 130. One writes down 120.
I mean, maybe you have reason to think that too. I mean, but that's what we're talking about is that you would say, 130.
I mean, I would assume like, okay, if my scale says like 125.8, Gail has never said that in my life. But if my scale were to say 125.8, I would assume it's somewhere between like 125.75 and 125.84 and like varying things in between.
Right. So you would say that it's certain to a 10th.
Certain to about a 10th.
Yeah. So whatever number plus or minus 1/10 of a pound.
Yeah.
That's the uncertainty. That's what we're talking about.
Okay. See, I was not far off with my answer.
In principle, that's what we're talking about.
Speaking of scales, I made Jake recalibrate my scale because I got a new one from my insurance. And when I stepped on it, it was reading 8 pounds different than my other scale.
It was legitimately.
Oh, no.
It was legitimately.
Yeah.
I'm like, listen, I'm going to need you to come up here and fix this because this thing is hurting my feelings and I'm just going to have to go back to bed and cry. No, it was legitimately uncalibrated. I was like, what? No.
Nice.
Hurt my feelings.
Okay. So
that would hurt my feelings.
In principle, that's what we're talking about here, is that precision with which you can be confident of measuring something about something. So like the scale was a good example of what we're talking about. But then we're going to drill down into kind of more complicated physics with this. So the actual Heisenberg Uncertainty Principle, like what you normally would see, is the uncertainty in the position of an object multiplied by the uncertainty in measuring its momentum is greater than or equal to a value which is a constant called h bar divided by 2. And that's just a number.
I have a question.
You don't need to worry about that, but yeah.
Relevant to this. So you said like an object.
Mm-hmm.
Is this talking about like in general an object, like a ball rolling down a hill, or is this principle like specific to planets in motion?
Technically in general, yes.
Okay.
Is the H bar related to the bar? Babar, get it?
I mean, it's at play at all times with all objects, technically.
Is there a specific physics situation where it's used most frequently?
Oh, at the very small scale.
Okay.
Yeah.
So like atoms, particles type situation.
And the reason is because of the constant that I mentioned at the end, h bar over 2.
Uh-huh.
It's a very, very small number. It's like 10 to the minus 31st or something like that. I forget, but very, very small. So if you have something...
You know what, Kayla? Damn, we're pretty smart.
If you have something that like a person that's very large and you can be like, oh, they're right there for sure, then the uncertainty and like the momentum, which is basically like how it moves, it, has to be within of 10 to the minus 31, like in your measurement. That means that
very hard
your
to
uncertainty
do.
momentum is very, very small too. So
this makes sense. I'm on board.
Yeah. But then when you're talking about small particles that are very, very tiny, have very, very small masses, and like the distance scales that you're talking about is very, very small, then it actually starts to have some power in what happens with it. So I'm going to give an example that it's going to kind of exhibit the power of this requirement or implications of that. But I did want to just mention like why, because I'm surprised you haven't already thought of this, but like you've asked a lot about like, why does this happen? Like this is just something that somebody kind of postulated and then they did the math to figure out like what that constant is. And it's just kind of like a consequence of nature. So there's not really a good reason why necessarily, but to get to the root of that is just a thing that we haven't talked a whole lot about yet, but is very important in physics, is the wave and particle duality of matter. Have you heard of that? That like everything is both a particle and a wave at the same time?
Nope.
You've never heard that? Okay, interesting. We'll need to do a whole topic about that.
Is this next week's topic?
Maybe. This is something that's really important and had that property of nature is really important for technological advancements in the earliest 20th century.
Early
20th century.
He has a lisp now.
The
earliest 21st century.
in any cases, you typically think of like these small things that we talk about, like electrons and protons and all these things as like small little particles that are zipping around. But
I have a question.
Yeah.
Are like atoms and electrons and whatever. I know those aren't the same thing, but here we are. Are they like spherical?
No.
No. I always imagine them as
That's
like
a lot
teeny
about that
tiny
actually
little
has a lot to do
balls.
with what we're talking about.
Teeny tiny little dots.
Yeah, a lot of people kind of think that they are balls. Now, remember we talked about the
Balls.
Higgs boson. Nice one.
Thanks.
And we talked a lot about fields and stuff like that.
Okay.
In reality, there's a lot of different fields that permeate the universe, and these particles are actually excitations of different fields throughout the universe.
What does that mean?
Really,
Give me that in different words.
remember, I think we talked about it with Higgs boson, but
I
how,
bet we
like,
did too,
you
but I
can
need,
think
like-
of like all of time and like the universe is like a grid system.
Right. I'm back there.
Yeah, so think of
But
like
the idea of like excitations of
yeah, so there's not just one field. There's the Higgs field, then there's like the electromagnetic field
got it.
throughout the entire universe. So you have like a small amount of energy in that field that is getting excited at some level, or like a wave moving through it. That field, a wave moving through that field ends up being a piece of matter that we can observe and look at.
So are particles a specific shape?
We really don't know. We know as far as we know, they are a infinitesimally small point in space, and they behave like waves as well. Because that's what I'm saying is that they are more of like a perturbation or excitation in a field.
Say that first word again.
Perturbation.
Perturbation. What does that mean? I love words. That is a fun one.
Perturbation is kind of like,
yeah, that's totally
it's like a
my
jiggling
description.
It's
of
like the jiggling.
It's like a jiggling.
So like Jello.
Like think about like being perturbed. So a perturbation of a field is like a jiggle in the field.
Oh my
like,
god!
Kind of sounds like a masturbation, a jiggle in the field.
You only made that connection because of Bayesian at the end.
So
Nothing
correct.
actually related to the term.
To the perturb part, not the Bayesian part, Kelsey.
Hey, being perturbed can have something to do with it.
In any case, we are on a completely different topic now.
I know, but like I'm invested like in this whole topic. Like I've been here.
In any case, there isn't really structure to anything. It's the way that the waves interact with each other with the different excitations in these fields that make up the different particles. And that's important with the next thing I'm going to talk about.
Okay.
But because everything behaves as a wave, that means that they have to obey very specific math that we've figured out. And that is kind of why the Heisenberg Uncertainty Principle exists. And I've got an analogy about like a real world analogy that can kind of exhibit why this is a specific consequence of things behaving like waves. So think about a lake, okay? And there's wind blowing across the lake. And you see waves going across the entire surface of that lake. If you were trying to describe to me the position of the wave that was caused on the lake, you couldn't really pinpoint one exact spot on that lake of where that wave originated or anything like that, right? Because it's like taking up the entire lake. But like if the wind was going a certain speed and you had the right equipment, you could say the waves are moving at X speed or whatever, 20 miles per hour, for example.
And they're coming from whatever direction.
Well, yeah, I suppose you'd be able to tell the direction too. That's important.
Yeah.
So you'd be able to tell like the direction that the waves were going and the speed that they were going, but you wouldn't really be able to describe the position of that wave very well. So that's one. And then on the other side of that, think about a still pool and somebody jumps into the pool and causes a wave.
Okay.
In that case, the like the wave is kind of dissipating from the one time that it got caused. So you're having a hard time determining what the exact speed of that is because it's varying, right? But you kind of know exactly where that wave started and came from.
Okay, I follow.
Mm-hmm.
So that's kind of something, that's the real world application related to waves, where in one case you can precisely measure like the location and have a hard time with the other thing, and then vice versa. So
I'm shockingly following this.
now let's go really
I am too.
This is a magical day.
My analogies are on point today.
They are, for real.
Now let's go small, and what the implications of this are to something on the small scale, okay? And that goes to our second question that I have, and that is, how do electrons move around an atom? Like, how would you describe their movement in terms of? Yeah, let's just start there.
I feel like it's like chaotic.
Elliptical.
Oh, we were using actual scientific terms.
Elliptical is okay, Kelsey.
Okay.
Like in an
like when you envision
formation?
an electron moving around an atom, what does it look like?
I envision like an elliptical orbit.
Right.
Like I envision the very traditional like atomic model.
Yeah.
Dot in the middle, elliptical.
Yeah. So you're literally thinking about like a ball orbiting another ball in a circle.
In my brain, yeah.
Yeah.
Whether it's right or wrong or otherwise, yeah, that's exactly what.
Mm-hmm.
Yes.
Okay. Now let's.
Is that okay? Now
It's
I feel
okay.
It's not allowed.
It's okay.
Okay.
I'm not going to tell you can't think of it that way.
I'm just going to tell you it's fucking wrong.
Yeah.
Of course.
So you've taken the bait.
Oh, fuck all.
So here's an interesting thing.
This is rich coming from the person who can't picture a star.
So, what?
That whole like picturing something in your brain.
You mean can picture perfectly a star?
That whole like picturing something in your brain shenanigans.
Yeah, I don't know why you're saying I can't.
But like you. Never
it's
mind.
just funny that when you asked me that, I thought of like a literal like ball of gas, like a burning star.
Oh yeah.
Can you picture the shape of a star?
I
like
can.
well, somebody were to say it.
Yeah, I'll say yeah. Have you
can.
seen this thing where it's like when someone says picture a red star, what do you see? Like
it's
in
just
your head.
more funny about like my like
Jake is like I see the sun
that goes to the astronomical object instead of like the 5-pointed object. I can
don't you
picture
have
both.
What is it though? Because like when I close my eye, like when you close your eyes, what do you see?
Do you actually, when you close your eyes, to like picture a star? Not what you imagine. Like, hey, when you say the word star, I think of this thing. Like, physically see in your mind.
I can.
I thought you were the one of the people that can't.
No,
you can't.
Your friend Molly is the person who can't.
Yeah. You cannot.
I can't.
There's nothing there.
Like you can't.
Girl.
Well, no, but in general, can you envision like shapes and people's faces?
No.
Or anything like that? Interesting.
I mean, I could give you description words to like describe to you what something looks like, but I can't inside of my head picture anything. No.
You should look up aphantasia.
I think we've had this conversation before because I was confused. I was mind blown about it one time because I like saw a TikTok about it and I was like, what the fuck?
Yes.
And so then I asked you about it and then I was shook that you can picture things inside of your
No,
I know what your thing is.
I have a very minimal internal monologue.
You don't have an internal monologue. That's your thing.
It's very minimal.
Yes.
It's minimal.
Mm-hmm.
Oh my God, I wish it was minimal.
Mine never
Mine's constant. Constant bitches droning on all the damn time.
Jake, when you're just like sitting inside of like when you're just sitting in a silent room, you don't hear your voice talking to yourself. Like,
not
what
constantly.
I should do today?
Not by any means. No.
Like,
I'm not saying it's gone. It definitely is there, but it's yeah.
Now,
but that's
okay,
because
let's put the combination.
I can think of in images. So
see, let's put the combination together though. Kelsey can't see anything in her mind. Jake can't hear anything in his mind. I can see and fucking hear. It is non-stop.
Sounds like you need to be highly medicated.
Sounds like I need to be medicated. I'm not highly medicated, for the record. Hey, anyone listening? I'm really not.
But you should be, though.
I'm on like mid-dose anxiety meds, and that's about it. Because, shocking, being able to see and hear everything makes a bitch anxious.
I can imagine. Maybe that's why I'm, you know.
Anyways, back to, where were we at? Picture, my atom. Okay, got it. See? Oh, come back around.
Yeah.
My very wrong shape of an atom image. Cool, cool.
Yep.
Got it.
Yeah.
So,
the what you're thinking of is called the Bohr model of the atom. And it's a good model in the sense that if you think of it that way, you can do some of the math and kind of actually come up with some of the observations that we've made in real life, like in practical experiments and stuff like that.
So not an entirely wrong envisioning?
In terms of like, if you could take a microscope and look at it, would it look like that? No. But in terms of like
practicality and
modeling
application.
it, yes.
Okay. See?
Yeah. And that's why it's still used and why it's still taught and all that type of stuff.
Okay, cool.
But if we take some of those ideas and look at the actual numbers, so in the Bohr model, you can calculate the radius of the electron going around a proton. Okay. And you can also figure out what the like speed of an electron going around in a circle would be. Okay.
Okay.
So
where's the question?
If you plug those numbers into the uncertainty principle, that equation that I quoted at the very top, you come up with a uncertainty in the position of the electron. Now I'm going to say the number, but it's not going to mean a whole lot with just by the number.
What do you mean by, hang on, coming back before you get to the number, what do you mean by uncertainty in the position?
No, I went through this whole example before, but I didn't. I just wanted to cut to the answer.
I'm sorry. You can cut to the answer. We can get back to this later.
Essentially, we're just going to do the math using like somebody did the math for me. But in any case, if you plug those values into the uncertainty principle, that equation at the top, you can solve for the uncertainty in the position. So we know the mass and the velocity, okay, which is momentum, is mass times velocity. And then divide that and you get the like uncertainty in the position is equal to a number there. And that number is 1.06 times 10 to the minus 10 meters. Okay.
It's a very small number.
That's a very small number. But the important thing is
we're
that
talking about atoms here, yeah.
The radius that we can calculate from that model is on the order of 10 to the minus 11 meters. Okay.
Okay.
So what's significant about between those two numbers, 10 to the minus 11 and 10 to the minus 10 meters?
One is like 100 times bigger.
Which one's bigger?
To the minus 10.
And what was that supposed to represent?
The uncertainty is bigger than
the radius.
That means... Okay, hang on. I've got this. It's here. I just need to evaluate. So, no. I really do. I like
walking you into these because you do a pretty good job at actually doing that.
I get it. I'm not a moron. So we're basically, okay, if the radius is this, we know the radius is this big. Obviously, it's much, much, much smaller because we're on a smile.
But
the radius is, my two hands making a circle.
Yep.
But the uncertainty about the position of where it is in that radius is bigger than that radius. That doesn't make a whole lot of sense. See, you get it, Kelsey? You follow me?
I am following what you're saying.
Okay, see?
So that's a very disturbing observation about the uncertainty principle. And
Heisenberg was...
We are less certain about where this particle is than we are about where it is.
Heisenberg was cooking, as they say. 100 years ago.
Let him cook.
Or was he cooked?
Sounds like he was cooked.
He cooked 100
No.
years, but he was not cooked. Because they let him cook back then.
Was he baked? Because for the love. Anyways.
Was he cooked in like any nuclear explosions because of his uncertainty or anything like that?
Well, he did work for the bad guys.
Oh, yeah, he did. He worked for the Nazis.
Well, forced to work for the bad guys.
That's true.
We should say.
So he was doing the cooking.
Oh, no. Kelsey,
Oh,
no.
I'm so sorry. That was so bad. I'm so sorry. I don't even know if we can leave that in.
This episode now needs a trigger warning because Kelsey's an
man.
asshole. Oh, my God.
On behalf of This Wasn't on the Test, we sincerely apologize.
Oh, God.
Kelsey doesn't know any better. She's not a doctor. She's sorry as fuck.
Oh, no.
Yeah.
No, Kelsey. No, he was
I'm
trying
so
to
sorry.
he was trying to make an atomic bomb. Like, Jesus Christ.
Oh.
You might have known that if you
Moving
watched
on.
Oppenheimer.
I know, you should have watched Oppenheimer.
I did watch Oppenheimer.
Oh.
Did you?
they-
Jesus
they
Christ,
mentioned
then
it,
why
didn't
are
they?
Oh my God. They sure did. Oh man.
Anyway, this has implications going back to like what we know about like the structure of an atom, and what that kind of ends up meaning is that like when you're trying to talk about the location of an electron in an atom, is that
This kind of feels like we have no fucking idea.
no, we do. We have a very good idea. Is that except that the location is more based on probability, and so they actually have calculated these of like based on other physics principles. There's actually kind of like a probability I'll say cloud, I guess, but there's like a region, a mathematical region where the electrons are allowed to exist, which have different shapes based on different energy levels inside of an atom. So like the first one is just like a sphere, I think. And so like at any point in time on the first energy level, like the electron could be found at any one point. So this is where the uncertainty principle comes in, is because if you go, where's the electron? You go, oh, it's right here. Well, actually, we have no idea about where it's moving. We just know it's right there. That's what the uncertainty principle means, because when you try to get more precise with the location, it means that you lose the precision in the motion of it. Then like the second energy level looks kind of like a barbell shape.
Okay.
And then like they kind of go up to higher and higher different shapes of where it looks like. So like different electrons and different energy levels are only allowed in certain regions around atoms, and they can kind of move around freely in there. It's just that they have, if you were going to try to make a measurement, they would only be found inside those different allowed regions for whichever energy level they're in. These are called orbitals. Kayla, you took chemistry. You might have heard that term before.
Did take chemistry.
But if you Google orbitals and like orbital shape or whatever, you'll see diagrams of what the different shapes of the orbitals are. Anyway, we need to get this moving along, and kind of relate this back to particle physics. And we'll try to go through this fast. But my third question is, how do you make something out of nothing?
Witchcraft.
Oh, it would have
Harry
definitely been
Potter.
deemed witchcraft back in its day.
No, for sure everything was witchcraft.
I mean, it is Harry's birthday tomorrow, so.
It's the only birthday I care about tomorrow.
Mm-hmm. Okay.
For the record, Kelsey's birthday is also tomorrow, but she's a bitch, so.
Yeah. She makes off-color jokes, so she doesn't
Yeah.
celebrate.
Correct. You're grounded from your birthday.
So I haven't mentioned the answer to this one.
How do you make something? Okay, we're
It's
talking.
really
okay,
important.
Okay.
related to my dissertation.
Oh, look at you bringing it back around. I don't.
Seeing as I couldn't understand any of the words in your dissertation, I
feel like this has to have something to do with like my actual guess is something to do with like particle collision and antimatter. I'm just
no.
Okay.
Kind of with collision.
With the collision,
antimatter doesn't matter.
Okay.
I mean, yes, it's in there, but not related.
Because I feel like let me explain. So I feel like when you're colliding particles, you are creating smaller and other things. So that feels a little something out of nothing to me. That's kind of where my logic came from.
Okay, I'll accept that answer. I suppose.
Oh my God!
I was asking
I'm 3
the
for
reason,
3 today.
I was asking the reason why that happens.
Oh,
but you are right that the thing that I'm asking for is exploited by doing the collisions, like you're saying. Yes, so I'll accept that.
Can I have an honorary doctorate in physics now?
No.
Fuck.
Yes.
So the uncertainty principle actually could be extended. It's not just this one precise or one specific thing that we're talking about in terms of the uncertainty in position and uncertainty in momentum. This is kind of like a universal maxim that can be applied to many other different things. So a different form of the uncertainty principle is that the uncertainty in energy multiplied by the uncertainty in time or lifetime, it has to be greater than or equal to h bar over 2. So, and this gives us access to a lot more interesting things when we're talking about time and energy. Are you about to say something, Kayla?
Nope. I was just trying to put it all together in my head and it wasn't fitting.
Okay. So, where I'm going with this then is that, so if you have energy that is uncertain by some amount, and it is available for some amount of time, the universe can use that extra energy and violate the conservation of energy.
What do you mean by the universe can use that extra energy?
So
give me that in dumb terms.
Yeah. So if you were going to, I have an example here, but I don't want to use it for this explanation.
Okay, sorry.
This is kind of like if you were trying to measure how long a particle lived. Okay.
Okay.
The more precisely that you're able to measure that, the more precise the measurement of that lifetime is, increases your uncertainty in the amount of energy that particle has.
Why?
Because it has to follow this principle because it acts like a wave in nature.
Yikes.
Yeah.
Touché.
But the interesting thing is that, like, well, it's something that did actually come into existence and then go out of existence based on its lifetime. So it's like, I wouldn't say infinite energy, but basically like like you get more and more energy has to be like available to the universe in that, in some sense, kind of as the, like, because of the lifetime of the particle. I'm not explaining this very well, but I think this next thing might give you a better idea.
Okay.
And like how it answers the question that I gave. So we're talking about the strong force here, which is one we've talked about before.
Which is not the strongest force.
Which is not the strongest force. The strong force you can think of like a rubber band. And so if you have two particles that are held together by the strong force and you try to pull them apart, it's like a rubber band. Like if you try to pull a rubber band apart, you feel more tension the further and further you're pulling the rubber band apart, right?
Okay. Yep.
So as that's happening, that tension is basically potential energy, okay? And the further and further you pull them apart, the higher that tension goes, which means that the potential energy goes up and up, okay? And so the universe sees that potential energy and thinks that that's essentially available. And so that energy that exists in that system means that the lifetime of things that don't even exist yet starts to become uncertain, such that they come into existence, and that energy is then granted to those things. And this is how you make something out
I'm
of
sorry,
nothing.
the fuck?
This 100% happens, and this is what happens when you collide particles, because you are forcing them to get split apart like that with kinetic energy. And so that potential energy that's stored in the strong force between those particles gets greater and greater. And instead of them snapping back together, the universe creates more particles to take their energy away from them.
That's fucking wild.
So that's how
I'm so lost.
But that's why, like, you can collide an electron and a positron together and get out hundreds of particles just by doing that. So
it's a lot to digest.
Nature's wild, yo.
Wow. So enthusiastic. Nature's wild, yo.
Mm-hmm.
That's about the peak Jake enthusiasm.
I don't know. I felt pretty excited in that conversation. Didn't it sound like it?
No.
That's weird. Have you seen those videos? Like, like, this is my husband's face on the best day of his life. This is
yeah, I've seen those.
This is his face on the worst day of his life. This is.
Yeah.
It's the same face.
All the same. That's funny.
That's Jake.
And then they usually will do like,
that's Jake.
This is my husband while watching Formula One.
While watching Formula One. Yeah. Right?
And he's like,
This is my husband the day our daughter was born. This is my husband when the Packers are winning.
Yeah. That's unfair. I was very excited about our daughter.
I know you were.
So yeah. But the main point there, Kelsey, is you were understanding what I was saying about rubber bands, right?
Yeah.
So like when you stretch a rubber band, you keep stretching. Eventually it snaps, right?
Yeah.
Well, that same type of idea is happening with two particles that are being pulled apart. And that snapping represents the release of that energy. But the way that the energy manifests, those particles continue traveling away from each other. That energy goes into making new particles because E equals mc squared. So energy equals mass, matter.
Mm-hmm.
So that's how that happens.
Yeah.
Cool.
Interesting. Cool. So thanks, Heisenberg, for all that uncertainty.
Hey, listen, I was following along about 80% of that.
I was following around along about 45% of it, which is a pretty high rate for me.
I'm disappointed we didn't make any
stuff.
Breaking Bad jokes this whole time.
I would have had to watch all of Breaking Bad in order to do that, and I've only watched parts of Breaking Bad.
But you know that his name was Heisenberg.
I didn't know that, actually.
So what, you watched the first episode of Breaking Bad?
No, I watched like a couple seasons.
And you didn't know his name was Heisenberg?
No, I fall asleep every time I watch anything.
Oh, okay.
So by watching a couple seasons, she's hoping she understands it via
understand it enough to like see some of the memes and laugh, and then that's pretty much it. Doesn't matter what it is, what show it is. I mean, remember we tried watching Barbie, and that's like a movie I would actually like love.
Oh my god!
And it took me like 8 times to watch it and watch the whole thing.
I just wanted somebody to say that it was time to cook at the beginning of this topic.
Well, we did end up saying that.
We did get there.
And then Kelsey took it somewhere else entirely.
Yeah.
So
we'll not talk about that again.
We're not.
Cool.
All right.
Okay,
sorry,
Jake.
I took a long time on that one, but it's
I think I felt like that one needed a long time. Mine is short today, so this is perfect.
Okay. Well, yeah,
Okay.
that's one of the more important topics in
great.
physics. So
I can't wait to bully you.
Here we go.
Been bullying you since I was a little kid.
all right, so now Kayla's going to talk about bullying.
You know, the thing that Kelsey has been doing to me for 20-something years. 23. Yeah.
To be clear, you've bullied me too.
Yeah, I have. Okay.
Yeah.
we're going to start off the top of the question. This is going to be a pretty short one, a lot more like conversational, but I have a lot of like statistics things. What % of students have reported bullying, like annually?
Actually reported it to their schools or just in general?
Well, I mean, like not even necessarily to their schools, just in general. I mean, it has to be reported in order to be recorded as a statistic. If you keep it in your brain, it can't go anywhere.
Yeah, so this is going to be something like they did survey students. How many of those students said that they'd have experiences with bullying?
Correct.
It's not like, hey, tell us it's not relying on somebody being proactive to go out to tell them about the bullying.
Yeah.
I mean,
to report it.
Right.
This is a survey.
Right. Okay. I'm going to say, I think it's higher, but of kids that will like actually say, like, because they don't want something to come back to them or something on a survey, I think like 73%.
Okay, I was going to say around 60.
I have great news for both of you. So this is in students ages 12 to 18. Okay. So in that age group, in 2010-2011 school year, 28% of students reported at least one incidence of bullying. In the 21-22 school year, it's actually down to 19%. 19% of students.
Well, again, to Kelsey's point, this is the reported.
Correct.
Yeah.
That is the problem. And so to kind of put it in a little bit more perspective, in terms of like the most common types of bullying, like this is not 1957. No one's shoving anyone into a locker anymore. Your most common types of bullying that students report experiencing is being the subject of rumors. And then, your traditional kind of like name calling, being made fun of.
Yeah.
Type situations. So in terms of the prevalence of bullying, it's supposedly getting better in terms of things. And I will say, like, as someone working in a school district, we have a lot more like avenues for students to report, including anonymous avenues and like very official anonymous avenues. Like we have I don't even remember if it's district-wide, statewide, something wide, like a bullying tip line where you can report and remain anonymous in your reporting. Should
kids
you
get bullied
so
at
choose?
School all the time and nothing ever happens about it. So
and here's I'm going to touch on this later a little bit, but a lot of the problem is the whole, I'm not saying like, oh, it's fine, kids should, be bullied, they're going to have to grow up at whatever. No, like it's not okay. But our biggest problem that we encounter, from my end and my experiences, is the reporting. It's because we'll get, parents who will call and be like, well, my kid has been bullied by this other kid all year long. And we're like, oh my God, who did they report that to someone like that? Why, how have we not taken care of this as well? No. Okay. Well, here's the thing.
You
can't do anything if we don't know what to do.
We have a kid in our after school program that's a huge bully, and he's been reported by like 10 or 15 different parents for being a bully, and like nothing ever happens to the kid. He's such a...
So we're gonna...
Does he have connections with the administration by chance?
That is a great question.
I don't know.
So I'm actually gonna skip questions related to this. Because we're on this topic, I'm gonna actually skip around. So my question is, what policies are in place regarding bullying at like the school district level?
I think I would assume that there's a policy that like if you hear something, you report it, like as a teacher or like as somebody in administration.
Oh, as a teacher, we have to that's
mandated reporting.
Mandated reporting.
Yeah.
Yeah. But I don't know if there's.
But the thing is, like, where's the line, right? Like, like what at what point? Like, you can't just be like, well, maybe they are. I don't know, but I don't think it logically and practically you can't just be like, this person called me dumb. Oh, well, now I've got to report it up to the principal in the district, or like at some you got to draw a line somewhere. Like what meets a threshold? Although that's really hard to do. I admit that I don't have the answer to that. So, but I don't actually know.
So here's what I've got for the district that I'm in. Their policy defines bullying as any repeated, and that's something we have to emphasize to the kids regularly, is that the difference between bullying versus harassment. Like, no, someone shouldn't like kick you in the shins underneath the desk. However, I'm going to need you to not tell me, well, he's bullying me. Oh, like what's going on? Well, he kicked me in the shins. It's happening every day? Like, why haven't I known about it? Well, no, he just did it this one time. Okay. I'm going to still need to deal with this. However, that's not what bullying is, friends. So it's even defined as repeated use of physical, verbal, or electronic, which is in middle school is where we see it the most, aggression or intimidation. So, I mean, and it's the year of our Lord 2025, and I guarantee you 9 out of 10 it's happening on a cell phone. Please, parents, check your kids' cell phones. Anyways, that's my 2 cents on that. But in terms of the other thing I wanted to look at is in terms of discipline, what the policy specifically was. And it varies depending upon the situation. However, it can be up to, discipline can vary up to suspension and or disciplinary review committee for expulsion. And that's in the district policy. Like, they're not fucking around.
Yeah.
Like, depending upon the situation and the circumstances, you can be expelled for bullying.
I mean, that's great that you guys have that in your district, but think about all of like the districts that are, underserved.
Oh, yeah.
And, none of that is, I mean, it might be in a policy somewhere, but it's not.
And the other problem is is it being enforced? Because the district isn't going to do anything until a school tells them about it. So if it's not being like handled or reviewed at a school level, it's never going to make it that far. And that's kind of the, like, in terms of my own observations and experiences, is it varies, how bullying is handled varies greatly depending upon how the school level how seriously the school level administration wants to take it and value that as a policy.
Mm-hmm.
Yes, Jake.
Do you have something to say, Jake?
Yeah, I've got a couple of questions.
Okay, cool.
Is expulsion at the school level or the district level?
District.
Oh, okay. That kind of nullifies some of my follow-up questions.
Yeah, so they can, I mean... So
is
they
it
can,
always at the district level?
Yes. So they can, at a disciplinary review hearing, they have a number of avenues that they can take and choices that they can make. And so there are in-betweens, like they could be suspended and then return to their home school. They can be sent to our alternative school for a period of time, and that's usually set in their like committee decision, like you're going to go to this other alternative program for this amount of time, or they can be expelled from the district.
Okay.
Wow.
In the cases where it's not expulsion from the district, but like there's a level where it's like you're not going back to that school, like that school doesn't want you, or we're not gonna. Is that one of
that? So, all of those decisions are made at the disciplinary would be made at a disciplinary review board. A school can't say, "I don't want that kid back." Like unless there's like there has to be very extreme circumstances before that's going to happen. Well, and at that point, if that's going to happen, then you're in that realm of expulsion.
Okay.
So a school can't make that decision. It's the disciplinary review board that reviews the situation and makes the determination, and the school has to go along with whatever that determination was.
I was interested in the case where they're not being expelled from the district, but the district says you need to go to a different school or maybe an alternative school, like.
In those situations, it would typically be like an alternative school placement for a set amount of time, or until certain behavior criteria are met, or like along those lines.
The question I wanted to ask is like, does that student get like some of the same services that they're due for the district? Like, I'm kind of thinking in terms of transportation.
Yes.
Like, the district has to provide them with transportation to the alternative school?
Yes.
Okay,
yes.
So that's interesting because, like...
And that is provided.
Yeah, but the district, they're kind of putting money up they are going to take disciplinary action against somebody.
Mm-hmm.
I guess is my point.
Correct.
Which is kind of an interesting dynamic because the district is somewhat motivated to not give that as extreme of discipline because it's going to cost them money.
Yes, but the disciplinary review board it's not at the district level. It sounds like it is, but it's not. So when there is a disciplinary hearing called for a specific student/situation, they arrange a disciplinary review board, which typically constitutes administrators from various non-involved schools. So it is, and with like a district representative, but it is a panel that, hear what the situation is and whatever. So it's not like, this situation goes to the Board of Education and they decide, like, ooh, let's not do that because of finance. Well, it's not the people in charge of the finances are not making those decisions. And I don't know from the back end if they are instructed like, hey, this costs us money, so be careful on doing this. I don't know because I'm not privy to those conversations. Yeah. But I do know that officially the format is set up in such a way that the people making the financial decisions are not the people making the disciplinary decisions.
My right-wing media tactic of going, I'm just asking questions.
No, you're fine. I'm just
pointing it out. It's interesting that there is technically a financial motivation to not discipline higher and higher. Now, I guess if they get expelled, then.
But then there are certain violations, and I don't know if there's anything under the umbrella of bullying that would fit this, but they're called title violations, and it has something to do with the specific statute that's like, title some whatever number.
Sure.
But if a student commits a title violation, it is an automatic alternative school placement. So there is no disciplinary. In those situations, there isn't a disciplinary review board. There isn't a, the student has committed this violation under this title, therefore this is what's happening. Period.
Interesting.
Sure.
So, anyways, shockingly, building relationships with students will mitigate most of these things. But that's neither here nor there.
Wow, amazing, because they just need somebody to talk to a lot of times. It is interesting, though, because I look at our public school district, not the one that my kids go to because it's a great district, but, we live in Milwaukee. So the Milwaukee Public School District gets a lot of shit. They are historically known. They're known throughout the country as one of the worst school districts in the entire country. They have some of the lowest. I think their graduation rate is at 20% right now. I mean, it is bad. I believe that most of the schools don't even do transportation to them because it's dangerous. And it's hard to find teachers, obviously. And, the ones that are teaching are really passionate about it in some cases, and in some cases they're not at all. So, these kids that are actually going to school might not even have the opportunity to build a relationship with their teachers because, they don't have that guidance or the people to even do it. So it's it'd be interesting to study underserved neighborhoods or school districts or whatever versus, it's one thing. I know that Kayla, your school district has areas where it's lower income people. Mm-hmm. And I think that it just crosses a totally different threshold when you get into an actual true inner city
school. Oh, for sure.
So it'd be interesting to study the differences there.
For sure. And all of this to say, I feel like a lot of what I've come to this with is no, teacher, we don't tolerate bullying. We don't. And we don't, but here's it comes down to a matter of who's willing to enforce the policy in terms of the policy's there for the enforcing. Is it going to be enforced? And then it's one of those situations where you're always going to have the good and the bad eggs in terms of adults. Cause I feel a lot of times the bullying conversation is well, no one did anything about it.
Yeah.
And that is a problem. But I feel it's one of those things, too, where you're always going to have the people that aren't doing what they're supposed to do. And for the vast majority of it, we're doing our best. I'm trying, man.
Well,
and the other thing is, too, when you have a class of, so Emmy, there's some scheduling things. We had more children who qualified for a more advanced math class than we had had in the past. Yay, great situation. But this poor teacher's roster had gotten to almost 40 students. And like when you have these classes that are, and that, you know, back to, you know, teacher shortages, blah, blah, blah. When you have these crazy classes like that, you're, especially without someone telling you and a student telling you, you're not seeing all this stuff happen. There are so many things happening in a classroom in a, 50-minute class period that it's like I'm building a plane while I'm flying it half the time and something's always on fire.
Yeah.
So.
The other thing is that, like, everybody's, like, because of the nature of being human, the people who get reported to are all going to have a different perspective on, like, the severity of the thing that they're being reported as well. And, like, I'm not saying, obviously there's people who don't rank things as severe as they probably should be, but I think the majority of, like, the bullying that happens is, at a small enough level that's dealt with, like, by having conversations with kids and not the, like, removing because they did such and so bad type of stuff.
Mm-hmm.
The point being that, like you're saying, Kayla, like, sometimes a teacher may just make a judgment call that, like, it didn't, from the evidence that I have from what I've been told, it didn't seem like a big deal to really go higher than what it did.
100%.
And people are going to make mistakes in that judgment from time to time. So it's really tricky, obviously.
Right. And unfortunately, it's very subjective. If you said something that, like, I felt really deeply wounded me, and I go to my teacher and I tell them that, and they just feel like it's like, okay, yeah, I understand why you're upset, but would an
example of that be like saying that it was harder to get my PhD than yours?
Oh, my fuck. Is that why it took you so damn long?
Yeah, exactly.
Or maybe I'm just better.
Oh.
Constantly bullied.
Well,
hey, let's focus on the repeated part of this because this has been fucking repeated.
Okay.
I am being bullied.
My PhD is more impressive.
Your dick is bigger, Jake. Congratulations. You have a bigger penis than I do.
This is all exhibitionary.
This is all a ruse to be able to say this to me?
Yeah, I was just joking about those things. No matter how true they are, it was just a joke.
I hate him. I hate him.
That's okay.
Okay.
I was giving an example in our bullying conversation here.
Oh, okay. Is that what it was?
Yeah.
No, but back to the point, it is very subjective, both in terms of whatever's happening in the actual situation and the perception of whoever is dealing with it at whatever level. And I mean, there are situations where it's like very, very clear, especially with most of these types of situations, especially at this age level, are happening on cell phones. And so when you have like that kind of very strong in your face evidence and a student is willing to report it, it's very easy to deal with. It's like the side things that happen under the radar that are difficult, and sometimes the right call isn't made when it is reported.
Yeah.
I think we need to do a whole,
that's where you.
I think we need to do a whole cyberbullying
topic
because I'm realizing how big that one by itself is.
It's huge. Oh my God.
I wanted to talk about that in this when I picked bullying, but I'm realizing that's
its own
way bigger.
Beast.
Yeah.
That is its own whole other thing, which is why I check our daughter's cell phone. Not only that, hers is really locked down, but the number of 11-year-olds walking around with completely unchecked, unmonitored,
probably with their
Guardian
Apple account set to being an adult as well.
Correct. And social media with free reign. Oh my God. It would make your skin crawl. And that is where 90% of the problems come in, is people with severely underdeveloped prefrontal cortices walking around with complete access and free reign to the internet.
Yeah, that's not good.
No, it's problematic. Anyways, I had a third question, but we've bypassed and gone into different places so far that I'm just going to skip it. And that's kind of that.
Cool. I think
that's
we had a good conversation.
That's the end of it. I said it's going to be shorter and conversational because of the nature of the topic.
Yep. And we'll do cyberbullying in the future.
Yeah.
For sure.
I think in general, your topics always will be shorter and conversational just because Jake's is data-driven and yours is
we all have much more experience with education, and as opposed to frickin' Physics McGee over here.
Right. Yeah.
Thanks.
Data-driven versus experience-driven. 100% will always.
I mean, that's entirely. I mean, that's essentially the difference between our entire dissertations. Like, that's the whole thing.
So Jake's is made up because science is fake, and yours is experience-based, which your experiences are fake too. So.
We're both fake doctors.
I'll tell you, it's hard to believe that some of this stuff in particle physics actually happens because
witchcraft.
It's so unintuitive.
You would have been burned at the stake. If this was 400 years ago, you'd be dead.
Yep.
They'd be cooking.
Freaking stop.
Yep.
I hate this. He'd be cooked.
He'd be cooked.
Oh my god. Okay. Anyways. So for next week, what are we...
I mean, we could delve in so deep into bullying. In different forms and stuff. Cyberbullying, yeah. But what are we thinking? What topics are we going to assign to each other?
I did not come prepared for this part.
Oh, I did.
Oh, good for you.
Hey, Jake, go for it.
Yeah, so, I thought apropos of the time of the year, I thought it'd be interesting to just have a little conversation about getting prepared for going back to school. Because, I mean, that's been, like we mentioned, that it's kind of been a whole different thing now that our kid is going to the next level of school, first of all, and going to school with you. But, I think people would be interested in to be like how much work teachers have to put in without, being there on a school day before they even get there for the first day.
Before their contract is even signed to start.
I will have it known that I paid 2 preteens in Starbucks to help me in my room today.
Out of your pocket.
Seems illegal. Just kidding.
Out of my pocket. Not with the permission of both of their parents. So I am one of their parents. So she didn't have a choice. Yes, I paid them in Starbucks out of my pocket. Yes, correct. Anyways, I don't have a topic for Jake. Can we just put a pin on that and I'll
surprise topic for Jake.
Or do you want to put a pause right here and give me a second to look something up?
Okay, we'll pause and I'll edit in what the topic is when I do the editing.
Oh, hang on.
The topic will be
quantum computing. And
then the audience will hear me in a very monotonous tone say whatever it is. And then it'll be here.
Perfect.
Yeah.
Can't wait to hear about
quantum computing.
All of the lovely things that you guys will have to say about
quantum computing.
The topic that Kayla is assigning.
And Kayla will never hear that section of the podcast because she doesn't listen to it. So.
Mm-hmm. Right. We could cut her voice out of the entire thing.
We could just cut her segment every episode and she would never know.
She would never know.
Alicia would tell me.
Alicia, don't tell Kayla. Okay? Got it? Get it? Got it good.
Alicia, I would like to remind you that I offered to bail you out of jail today should you commit a homicide.
Alicia, I will bail you out of jail.
Alicia,
actually,
Kelsey.
Kayla will have to bail both of us.
Alicia,
Kayla
Kelsey doesn't have the money to bail you out of jail.
Kayla will have to bail both of us out because I'll be right there with you, girl. Got it?
Stop it. You can't have her. She's my friend.
I bet she would like to be my friend.
I don't even like you.
Mm-hmm. Great. Well, this concludes today. How exciting. I
feel like we're back in it.
Wow.
We're back in it.
We are back in it. We're back in the swing. We're back in our topics. And next step.
Did you learn a lot this time, Kelsey?
I did. I learn a lot every single time. Actually, there's been a lot of times where people have been talking about things just colleagues or whatever in meetings and stuff. And I'm like, oh, actually, I know about that. Or I'll be like, oh, yeah, that reminds me of whatever X, Y, and Z, So
awesome.
I am learning a lot. Yeah.
You too, listener, can do the same if you listen to all of our previous episodes.
And follow, subscribe, rate, review. Follow us on TikTok, on Instagram, wherever you get your podcast, YouTube, all the things.
All of the
everywhere.
Places.
Yep.
Everywhere. Okay, well, have a great week, guys. Thanks again for joining us, and join us next time to find out why this wasn't on the test. Bye.
Bye.